Okay, welcome back to part 2. In this example, we are trying to test a hypothesis for a population mean, or test an idea about an average for a population. In this specific video, we are focusing on a right tail test. So the first thing let's do is let's read this question and see what's going on here. According to the Crown ATM network, the mean ATM withdrawal is $58. A president of a local bank reviewed 40 withdrawals and discovered his sample had a mean withdrawal of $64 with a standard deviation of $18.50. He believes that the ATM at his bank has a higher average withdrawal. Test his claim at the 0.05 level of significance. So let's try this out. Step 1, we're going to write our null mu equals $58, or our alternate mu is greater than $58. So what we're saying is here, his sample indicates that it's more than 58. Just because he has 64 in his sample doesn't mean he believes all of the time his overall average is 64. There's some wiggle room. Now our test is determine the significance of his sample. And that's what the p-value will do. So in step 2, we pick an alpha. That's already been picked. Alpha is our significance level. Right? Now we're going to find a test stat. So our test stat is x bar minus mu naught s divided by square root of n. So in our case, x bar is his sample average, $64 minus the specified value, 58, divided by s, 1850, over square root of 40. So let's compute this. Find our calculator here. So remember, it was 64 minus 58 divided by, and I'm going to put this in square roots, 1850 divided by square root of my sample size, 40. Close the parentheses. 2.051. 2.051. So here we have now what's going on here is we have a bell curve. And my sample is approximately normal. So what I'm going to do here is about what would the p-value be. Now, this is not exactly a bell curve. So instead of using a z-score, I'm using a t-score. So if you remember, let me erase this. 0's in the middle, then 1 is at the inflection point, and then 2, 3. But this curve might be a little bit flatter. And I had about my test stat is 2.051, and I want the area beyond that test stat. So my goal here is to find that area. So instead of normal CDF, I'm going to do something called the T-CDF, 2.05, right? From that point on will be my p-value. And so this will be 1E99. The mean is 0, the standard deviation 1, but the degrees of freedom is 39. So let's keep that in mind. Go back to the calculator for a second, and we're going to do let's quit. Okay. Open that again. Second distribution, and we want TCDF lower 2.051, upper, in our case it's 1E99, and our degree of freedom, comma, 39, enter. So we get our p-value at 0.0235. So this has an area of 0.0235. So let's see what happens here. Our conclusion is, since our p-value is less than alpha, we go ahead and reject the null. Go back up and let's see what that means. So we reject the idea, right? We reject this. So basically we're doing something like this. Reject that idea. So it's as if we're saying the bank teller is right, the average is actually more than 58 because we rejected the null hypothesis. All right, thank you for watching this example. Next, we're going to do an example of a two-tailed test.